Record. Okay. Yeah, sorry about that, Yasmin. It wasn't you. People are getting quite brave, though, much more familiar with the technology and the environment, the online environment, and jumping in. Morning, Sonia. Okay, jumping in, you're opening the mics and talking, which is great. Okay. Sebastian, morning to you. So, okay, I think it's a good time to start. The recording's on. So thanks. A few changes to the timetable this week. I might have started this a little bit too early, I think. The show, I'll just end the show. Just following my outline last week, a couple of little changes. You've all been absolutely fabulous with your participation and everything. It's been really great. So I've got the online lecture here. The rest will be drop-in centres. So you'll know someone will be online if you need to. And got a fair bit of email traffic from a few people last week, which is great, just about maybe having a second live session. So we're going to go with Friday, 8 a.m. for our second live session. So it'll be a repeat of what we do here. It'll happen there. And why? Well, I got about 15 people to that session, and on average, and they're pretty keen to have another one. So this one's live now and recorded. These are drop-in times, and I'll make an announcement later that that'll be another live time. Okay, is that all good with everyone? No one's unhappy about that? Yeah, sorry, yes. Sorry, yes, the 8 a.m. will go ahead. I just didn't want to put up too many announcements about changing it. I did speak to the 8 a.m. Friday people. I just didn't want to put another announcement out saying another change. So that's cool. If you want to zip out now and come back Friday at 8 a.m., you'll hear this again. So 2 live sessions, start of the week, end of the week, and drop-in sessions. Oh, Trudy's off. See you, Trudy. Yeah, no problems. That's all right. Yeah, look, 10, yeah, we'll probably, finish off next week. That's fine, guys. Sorry, I didn't want to cause you any confusion or concern, but I'm going to get started, okay? So we've got a fair bit to do. We've hit Homo sapiens. We've hit our species. So we did look at life and evolution, and I hope that you've gone through the module now, because it'll make much more sense if you've gone through the module. Remember, this is just a guide to get you through the module, and you have to do a fair bit of follow-up with the module, and of course in and out of BHP. Homo sapiens, this is us. Crazy. There's our family tree. We're in there somewhere. It's so we're going to be looking at our species and how our species evolved in particular. It's really quite fascinating. Okie dokie. Oh yes, and of course you know that the online test for thresholds 1, 2, 3, 4, 5 is now open, and it'll stay open, of course, till May 4th. Yep. So you can jump in and do that whenever you like. All good to go? So we're good to go? Yep, fantastic. And Rose is here, of course, and she'll keep an eye on the chat room for me. So if you've got questions, pop in. Or open your mic and speak. That's always a good thing to do. Helps us out enormously. Okay. Just getting my chat room organised where I can see things. Okay, let's go. Here we are. Okay, so what are we on about? We're on about understanding our species, Homo sapiens. Yep, we'll learn about our ancestors and how they evolved. And this is an evidence-based story. So the fossil record, generic dating, and the study of primates are really good things. You've all heard of Jane Goodall? Yes? Yeah? Yeah, right. Yeah, with the chimps, yeah? Yeah, kind of. Yeah, she's done, she's a very famous scientist, primatologist, who's spent years and years and years living in the jungles, studying behaviour of primates, particularly chimpanzees, and and her and others. Diane Fossey was another one. Diane Fossey, you might remember from Gorillas in the Mist. They made a movie about her. She studied gorillas. So we learn a lot about our species by looking at our distant relatives' species. Yeah. We're going to finish on collective learning, and collective learning is key to our success as a species. So we'll finish on collective learning. We'll also touch on colonisation of Australia by Aboriginal people, and there's two main debates which we'll get to: the out of Africa, two main debates about the evolution of our species. There's the out of Africa theory, which is the dominant one, and emerging one out of China. And it's emerging because of new evidence. So we're finding new evidence all the time. So we get it, and that's what science is about. Making the best out of the information we have at the time. Yeah. So there is a debate. It's been going for a few years now about out of Africa, out of China for our species. So let's get into it. Okay, just a quick recap on life. What are the 4 qualities all living things can do? Metabolize, homeostasis, reproduction, adaptation. You've got to have those terms in your head, and you've got to understand what those processes are. They're the critical qualities for life. Yep. So be able to describe each quality. Metabolism, taking energy from surroundings. Homeostasis, the ability to regulate internal conditions. This all should be familiar from last week. Reproduction, well, obviously we pass on DNA, and that's really critical. Yeah, and that's how traits essentially get passed on. And the 4th quality is adaptation. And our understanding of DNA tells us that every 10 billion copies or so, every 10 billion runs of DNA, when we have a copy, there's an error. And if that error is beneficial to the species, it remains. If it's not, obviously, it dies out. But we see how that error gets passed on if it's useful for the organism. Okay, so this all should be familiar ground. Yes? Yeah, no surprises there. If you've done the module, you should be all over that. Yep, fantastic. Thank you for those people commenting. That's really excellent. Most excellent. Darwin, of course, he's a key player in this. Darwin knew that animal breeders could actually change a species. When we finish today, next week is agriculture, okay? And we're going to talk about the agricultural revolution, which started about 12,500 years ago in different places around the world. But since then, we've been changing species. Yeah, we can do it by selective breeding. Yeah, so we notice a trait that's a mistake of DNA, and we breed from those individuals. And I used the example last week of brassicas. Yeah, cabbages, broccoli, cauliflower, Brussels sprouts. Good news on the Brussels sprouts. My Brussels sprouts were pretty much decimated by white moth. I don't like using chemicals and stuff, so I had some other remedies that failed, so I have to pull out the Brussels sprouts. Yay! Happy days, happy days. I can pull out my Brussels sprouts. Okay. So, I think in the video you saw with David, he talks about just kill the moths. Yeah, but I want to do that in a non-toxic way. Said to kill the moths, I want to maintain my own little, you know, organic status garden. So in the video, David talked about the example with the eagles with the good eyesight. Yeah, the better the eyesight, the more successful that species would be. Yeah, so the good eyesight gene, if you want, gets passed on. And the eagle with poor eyesight, well, that gene's obviously going to die out. You know, those genes won't get passed on. Now, remember, this just doesn't happen over 1 or 2 generations. It's repeated many thousands of times and even through millions of generations is how we get those changes. But we can see evolution happening before our eyes in bacteria, because their generations repeat very quickly in bacteria. And we've seen in the last 2 decades, even particularly in the last decade, bacterial resistance to antibiotics. And we know antibiotics only work against bacterial infections, not viral infections. Okay, but that's evolution at work. And evolution doesn't stand still. We are still evolving. So you can't see it from generation to generation, but we can see it over a few thousand generations. And we'll talk a bit about that later on. Okay, comments? All good? Oh yeah, that's true. Tiama, I got it right? Yes? Yeah, let's just, you know, let's all just take a mouthful of Dettol and rinse it round. Or the ultraviolet light one was interesting, like maybe expose, did the president say, Trump say, expose the body to light externally or internally? Ooh. Ooh. Yes, Annabelle, as a species, we are a little taller. Generally, we're getting a bit taller. Our brains are getting smaller, which is sort of sounds a bit funny because we're getting so much smarter. Some of us are. But our brains, even though they're smaller, they're much more efficient. Yeah, man, crazy stuff. Talk about science literacy. Yeah, wowzers. Crazy stuff. I even saw a YouTube face chat thing, you know, that stuff we do, on the current vice president talking about evolution as a theory, and it's only a theory, and it's a poor theory without much support. That's why intelligent design should be taught in American schools. And intelligent design is creation by a deity. You know, God made the world. That's all there is to it. From that perspective. But if you want to weigh up the evidence, I don't know. Okay, so let's go. Darwin, natural selection. Now, Darwin did talk about, well, when we do talk about Darwin, we talk about evolution and the theory of evolution. And remember what I said about a theory? A theory in science is something that's well supported. Yeah, and every bit of evidence we've found over the last couple of 100 years supports this theory. Even when we learned a bit more about DNA and how to use it, that supports this theory. So the theory of evolution is getting stronger and stronger all the time. But Darwin talked about natural selection, and that's really important to remember. And his book wasn't The Theory of Evolution. He wrote several books, many books and papers. His book was The Origins of Species, and it was about natural selection. So natural selection is the key to evolution. And we've spoken about that enough, I think. Okay, so here we go. Let's look at us. We're primates. We're a special type of mammal. And primates really started to evolve at the time dinosaurs came extinct. Dinosaurs dominated the world, the early Earth, for what, 150 million years? And they occupied all aspects of the Earth. That made it very hard for other species, i.e. mammals, to get a hold. So mammals were small and they lived on the fringes in fairly specialised niches that dinosaurs didn't have to bother. There wasn't much crossover, you know, they didn't compete for many things. Get rid of the dinosaurs and we have evolution. Generally, you know, my views on this type of image, it can be quite misleading, although this looks like it's a bit like some sort of alien has come into our hereditary line here. Okay, so our species, this is really critical, our species, Homo sapien, has only been around for 200,000 years. That's what the fossil record tells us. Our species, Homo sapien, are only around for a couple 100,000 years. Okay? Now, so it's not as if we were totally new and just emerged. Yeah? We evolved from other animals. It wasn't just 200,000 years ago, oh, here's a modern person, modern people. Didn't happen like that. We go back here in the millions of years across the top, and it's calibrated in such a way that we can fit it on the page, okay? We do have a common ancestor of all apes. Indeed, remember, we have a common ancestor for all living things, which is LUCA, the last universal common ancestor. So that's a bacteria, right? Okay, so we go back 9 million years, we have a common ancestor of humans and great apes. And we started to break up into families, the hominin family and the gorillanine family, which leads to the great apes, yeah? So going back to this picture, we did not evolve from monkeys, right? We share a common ancestor, all right? And we don't know much about this line here because I know what I need to do. I need to get my laser pen out. We don't know much about this line, right? Because this was in tropical sort of jungles where they stayed, yeah? And bones and everything breaks down really quickly and it's hard to get fossils out of tropical places, right? However, during this split, we moved out of, our family line moved away from the jungles and into the grasslands, yeah? Okay. Okay. So this one's going the other way from now to, it's going left to right. The other one went right to left, all right? Okay, so we don't follow a clear linear line. There's lots of twists and turns on the way, yeah? Okay, and we didn't find this evidence in order. We found bits of this, then bits of this, and then bits of this, and then bits of this, all at different times. So it took some time to build up a coherent sort of story. There is no missing link. You often hear people talk about, you know, the supposed missing link. There isn't a missing link in our evolutionary tree. There maybe was 60, 70 years ago, but there were lots of missing bits. Yeah, but we've been able to fill that in much more substantively. Yeah, so we have a really, really good understanding of our ancestry going back 8-9 million years. So for a species, 200,000 years, we're fairly new on the block. Yeah. Okay. So we are now we're going to get into some taxonomy in a minute, and we're going to break and explain what taxonomy is. But we are hominids, a primate of a family which includes humans. So we're hominids. Yeah. We didn't all exist at the same time, but early humans did share the earth with perhaps around 12 to 20 different types of hominids. And the most common, I think, that would spring to mind would be Neanderthal. And we've come a long way. So let's have a look at our family. By the way, down the bottom here is this link to some folks from the University of New South Wales, which talks about our evolution as a species, which is really, really amazing. So I'd have a watch of that because it answers that question, are we still evolving, really well? And the answer is yes, we are evolving. So this may be familiar to you, yes? Looking at the chat box, we have kingdoms of life, and we break these kingdoms into 5 main areas, sometimes 6, because we can break the kingdom of protists into other subgroups. So sometimes there's 6, but you would have seen this before, the different kingdoms. Protists are the protozans and the algaes. Monorans, the kingdom of monorans is the bacterias. Fungi and yeast have their own kingdom because they're separate. So these kingdoms are broad groupings, if you like. We have the kingdom of plants, and then we have the kingdom of animals. And you can see within each kingdom there are subgroups where we break things down even further. Yeah. All right. So we understand that there's different kingdoms, and we of course are in kingdom Animalia, from the Latin Animalia. Right. So taxonomy. Taxonomy is that part of biology where we classify living things. And it's binomial nomenclature. I'm sounding like Donald Trump now, trying to mispronounce words. Words that are well known, and you look at them on the screen and you get all tongue-tied. Nomenclature. So it's just the names we give things, okay? And this is how we go about it. I'm just trying to move something on my screen which you can't see, but I need my pointer back. I can't get him back. Anyway, there we go. So, there we are. I can move that. Oh, I can't move it. Yeah, I can. Okay, so how do we do things? Well, we break things up into their names. So their life, their domain, their kingdom. Yeah. And we keep going down the order, and we can classify things using and developing a proper scientific name so we know where things belong. Okay. It's based on evolutionary relationships. Yeah. So what's ours? What's ours as people? Well, here's ours. We're in the kingdom, Animalia. Yeah. The phylum, Chordata. The class, well, we're mammals. What part of mammals? Whoops. What part of mammals? We're in the primate section. Our suborder is Haplorin. Our infraorder is Semiphines. You don't need to worry too much about these. You just got to understand what the process is, because everything on Earth gets classified into a taxonomy. Our family is Hominidae, so you see here's our family. Yeah. And our genus is Homo, so we're in the Homo genus along this line, and our species is Homo sapien. Yep. So often when you look at scientific text, you'll see this sort of classification of life. Yeah? Okay. And see this group, chimpanzee, yeah? And close cousin of the chimpanzee is bonobos, and we'll talk about them a bit later. Because they have some very, very similar species, but they have some key differences in their social order and how they behave, which is quite fascinating, which gives us an insight into our lives. All good so far? Everyone okay? Yep. Thanks, Tonya. Yep. Questions? You've seen this sort of scientific ordering before? Yep. Okay, we're not going to get too into it. We just got to know what it is and how it works. But it's always good to remember where we belong on this tree and we're here. Okay. So, phylogenetics is really the study of biology, yeah, the historical biology. So if we move down this line, here's our first lot of primates, right? And these are all the lines where there's clear breaks in the family. Yep. And there are other breaks along here. Yeah. Until you end up with us, sapiens. Right. Now, were there breaks like this in here and other family lineages and lines? Probably. More than likely. Do we have much evidence of that? Nope. Why? They stayed in the jungles. We went out onto the grasslands. Yeah. So we split from the chimps, the Pan family, 7 million years ago. So just remember some of those key understandings. Anthropolithecines are our earliest bipedal relatives. All right, so what I hope you could do now, you probably could have done it before, but you should be pretty confident explaining to someone else that we are not evolved from monkeys. Did I say condiment? I've got to wear, my glasses are dirty. You should be not condiment, confident. I don't like autospellers. Okay, you should be confident in that explanation. If you're not, keep reviewing your notes until you are. It's a very easy conversation to have with someone when they say, but I can't believe we're descended from monkeys. Well, you should be able to draw a picture and explain that with a fair bit of detail. Okay. This is the key resource in this. Yep, only 10 minutes of how our ancestors evolved, and it's really thorough. So please make sure you have a look at that video. If you're watching this as a recording, you might want to stop here now and go and watch the video. But remember, this is all evidence-based. We didn't just make this up. We haven't got a couple of little bits of stuff. Our fossil record is extensive, super extensive. And we can use genetic dating. DNA has been fantastic because it can help us identify these common ancestors. And with the fossil record, we can use a number of aging techniques, from understanding radioactivity to being able to determine when a particular thing last saw light. Yeah. So there's the module really explains some techniques and talks in some of the talking with the real scientists things sections in the module. There's some reference to all the different types of dating we can do to fossils. And of course, modern studies. We look at our early, we look at our distant relatives, and we can learn a lot about ourselves and our life and how we evolved. If we just go back to bonobos for a second, Okay, so we're all pretty familiar with chimps, and bonobos are a pan, right? Same family, yeah, pan, very close cousins, very similar, but they do some really different things. For example, chimpanzees are socially organized through male dominance. Yep. So really big, muscular, aggressive males. And you're probably spinning off from The Lion King. You may have seen some of Louis Theroux's TV documentaries, and he's done one on exotic pets, world's most dangerous pets. And while chimpanzees as babies can be quite cute, and many overindulged rich people like to have them as pets, once they reach adolescence and sexual maturity, they can be really, really quite savage and can literally tear limbs off people with their strength, right? Now, chimpanzees are organised in a patriarchal society with dominant males. So let's apply a little bit of the natural selection there. The most aggressive, biggest and aggressive males, genes get passed on. Yeah? Yeah, you've seen that story, Chelsea. Yeah, it's pretty. Ah, Sebastian, you're right on the money today, aren't you? Yes, the documentary doesn't have any limbs being pulled off people. All right. However, so you can see what happens, can't you? So chimps, the most aggressive males are the dominant males, and they get to breed. Their genes get bred in. So over thousands and millions of generations, patriarchal and built on aggressive males. So what happens when two chimp gangs meet? Warfare. Really warfare. I wasn't even joking, huh? That was a literary question. Sorry, Sebastian. Yes, no, I'm afraid no limbs get pulled off in the movie, in the documentary, but they do refer to a lady who was visiting a chimp owner, or a chimp got out and literally ripped a lady's face off. Anyway, so when chimp troops get into conflict, it's warfare. Males get literally into war parties, and they raid, and they attack, and then they retreat, and then the other side do the same thing. It's really, really savage. So look up some docos on the life of chimps. However, bonobos are matriarchal. Okay, so the dominant females run the show. Okay, and the males are not very aggressive. In fact, when males are aggressive to females in bonobo troops, a group of females go and sort out the male and really give him a rough time physically. So you can see what happens with natural selection on that side. Yeah. So there's not going to be many aggressive males, because the females will only mate with the passive males. They beat up and exclude the aggressive males. So what happens when two bonobo groups meet? Well, the males are at the back because they're timid. The females meet, they greet each other, go straight past the other females to their males, and mate with the males. So the whole thing's built around love and sex, as opposed to chimpanzees, where the whole thing's built about, war. It's really quite amazing. Not only do the females go and seek out the males and have sex with them to calm down the situation, they also practice homosexuality. In fact, young male bonobos are highly promiscuous in their homosexuality. It's just crazy. But it's a really good example of genes at work. By the way, there are several mammals that exhibit homosexual tendencies. Several mammalian animals that practice homosexuality, right? Bonobos are one, whales are another. Okay, so when someone says, you know, homosexuality, that's unnatural, well, yeah, it is. Sorry to say. Just saying. I'm full of fun facts, yeah? Oh, I didn't like that one, Sebastian. Had nothing to say. Sheep, cattle, seen out my window every day. yeah. Some of that's expressing dominant behaviour, and some of it is sexual. But yes, homosexuality among. So why do we do this? Why do we study bonobos? Why do we study chimps? Why do we study gorillas? Because that gives us an indication of how our early ancestors may have behaved. Yeah. Exactly, Sebastian. Yeah. It's a window into the past that we can see right now. Yeah. Crazy stuff. I really love it. Okay. So watch that video. Fossil record, genetic dating, modern studies. Very, very important for us to understand our story. Okay. What are the three? There are three defining qualities of primates. So hands and preferably feet. Yeah. If you can grip with your hands and preferably grip with your feet, you can climb up and get things, which is pretty cool. Stereoscopic vision, right? Two eyes facing forward. Two eyes facing forward. Really, really important. Yeah, gives us a really good view of our world. Lets us see really clearly. Lets us see in 3 dimensions. Yeah, and big brains. They're the 3 things that are common in our bigger family, our bigger primate family. Yeah. Okay, but why are we different? Why are we different from other primates? Well, it's not just even Homo sapiens, it's the whole Homo family, right? What is it? Bipedalism. We could stand on 2 feet. That's the short answer. And why did they become bipedal? Well, if you're living out here on the savannas, yeah, you can travel a lot faster and further on 2 feet. Yep. And you've got better visibility of what's around you. Yep. And your hands can now carry yes, Sebastian. Sometimes is really for a short time. It can't be maintained. Yep. They can't stand up and walk consistently. It can sort of be a really awkward sort of run, but it can't be sustained. Yep. Okay. So if you can carry your young and look after your young, yeah, that means some changes for your young, right? And our species, because we have such big brains, right? It takes a long time for this little infant to grow and learn. Yeah. So with hands, we can nurture and protect. We can also start to carry tools. And I've just noticed on this picture, I don't know what this bloke's doing here. That wasn't the sort of tool I was talking about. Anyway, sorry, I'm being silly now. But we could start to make weapons, yeah? So now we're much more mobile. We've got some distinct advantages. So this opens up a whole new niche. Sorry, Sebastian. A whole new niche, doesn't it? Yeah? So not only could we just expand into the grasslands, as a species, we could expand to every continent except Antarctica. Pretty amazing. So what happens when we fill a niche? There's sort of it's nearly like an adaptive radiation, isn't there? Because now we're out of the jungle, we're onto this brand new niche, this brand new area. So we're going to see a whole lot of evolution, adaptation. So our ancestors flourished. And here's some of that ancestral work. So the letters correspond with different species, and the species are listed on the left. Some of our early ancestors, end of the line. Yeah. What are the question marks for? Yes, good question. We're still looking for information there. We assume that there's a link, but we've got to get that information down a bit more solidly. Yeah, there are, yeah, not really. I think when we talk about the missing link, the missing link was meant that there was some huge gap, right? There is no huge gap. There is no missing link, but there's more information for us to find out about. Yeah, we can't put the solid story together yet. Yeah, a small gap if you like, but the story moves forward. It's not enough of a gap to stop those story going forward. Yeah, when people historically talk about the missing link, it was here's evolution, but there's this big gap here, and so this means evolution can't be true. Good question, Annabelle. Make sense? So there is no missing link like that. But these are all our known ancestors. This is all part of our broader family. This is fantastic. And of course, you know how much I love the Khan Academy, so I'm not going to say any more about it. But if you want to watch this, it's a really, really good clip. You can do that in your own time. So if you're watching this as a recording, you can stop now and go and watch. Let's have a look at some of our ancestors. Australopithecus. 4 to 1 million years ago. The best known one is Lucy. That's our best skeletal names of Australopithecus. Now, big family in this are the Leakeys. Yep. They are, to understanding the evolution of our species, what Hubble is. Yeah, they're really important. There's a lot in them in the modules about the Leakeys. Anyone know why they called Lucy Lucy when they found the complete skeleton? Well, the most complete skeleton of Australopithecus. It's a really cool story. Anyone know why? Why did they decide to call her Lucy? Oh, that's a good one. Nice one. Tiama. Nothing to do with Luca. It's a little bit confusing. Well, on these digs, you know, on these excavations, you know, pretty dull and boring. And if you've done labouring work and stuff, what do you have on? You have on the radio, don't you? Oop. Put the radio on, and there they are, digging away, putting dirt through sieves, finding little bits of bone. And what comes on the radio at the time that they're finding Lucy? The Beatles with Lucy in the Sky with Diamonds. Ta-da! Yep. So it could have been Jude, as in, hey Jude. It could have been Eleanor Rigby. It could have been Desmond. Desmond Silverhammer. These are all Beatles songs. Or maybe they were just on LSD. Yeah, funny. So 1974, into Ethiopia, a big dig going on, and they find the most complete skeleton of Australopithecus, and it gets called Lucy. About the size, the brain's about the size as a chimp. But what do we know from the skeletal remains? Lucy was bipedal. Yeah, made that critical transition. Homo habilis. Habilis means habit, as in tools, could do things. Yeah, habilis. Also sort of handyman, I guess, because there were lots of tools found. Slightly larger brains than Australopithecines, but overlapped. Yeah. So here's some evolution found in the Rift Valley. Louis Leakey was convinced to be human, you had to make tools. What do you think? What is it to be human? Where do we draw the line? For Louis Leakey, you had to make tools. So what is it to be human? When do we draw the line? Yes, Annabelle, animals can make tools. Birds can make tools. Chimps make tools. Interesting question. Okay. And Homo erectus augusta, about 2 million years ago. So the time frames are for Lucy, for habilis, for erectus. They were all around. There were times when they were all around. Yeah, their times overlapped, right? And this is adaptation and evolution at work. Almost as much taller, almost as tall as modern human. And they travelled. They walked out of Africa. Homo erectus augusta can be found around for a long time, everywhere. Yeah, they really walked. They really got out. And it didn't happen in like 3 days. They didn't pack their bag and go, which consisted of a rock, and go, okay, I'm going to China now. You can see how new grounds opened up, and Augusta could accommodate and make small adaptations and find environments to live. Augusta was around 30,000 years. We've been around 200,000 years. Yeah. So if this is Augusta, yep, they were around when we were around. Yeah. And not just make tools, They should be tools, not tones. They made really nice tools. Yeah. What killed them off? Not sure. Probably outcompeted. They probably had a more competitive neighbour. Us. Yeah. May have been some changes in climate they couldn't deal with. But what makes us so different? So there's a selection of all our ancestors. What makes us so different? And there's a crow using a tool. Language. Yes, Tiama, I think language. What's IDK? We were better looking. I don't know. Really? Anyway. Oh, I don't know. Oh, thanks. Helping out the old person with the hip, you know, techno language of the interweb thing. Cool. Yes, collective learning is the key here. So this is just, let's get on to this. This is what happened. So here's our species first emerged. Yeah, this is when we start to see our species. Yeah. There's Homo Neanderthal and Homo erectus, right? So you can see where Neanderthal went. Yeah. You can see where erectus went. Yeah. And you can see where we went, right? We walked out of Africa. We followed there, well, you know, because we could deal with that. They couldn't deal with this. We could. They couldn't deal with this. We could. No. Well, good point. Yes. And this is the world map just sort of showing how it happened. But of course, there were land bridges and different different sea levels and things. But our continents were really changed billions of years ago, right? Now we're talking a few 100,000 years ago where things were pretty settled. Yeah. Okay. The world hasn't changed much in 12,000 years except for some sea levels. And we got ice ages where we had, there were several ice ages, but no, they weren't mass extinction events, right? So we could move. And of course, this wasn't all get out of Africa. Some of this was come back to Africa too. Yeah. Okay. But where we went, we could go a bit further. So we were very similar. Homo sapien, Neanderthals, and Erectus, we all did this. We all did a similar thing, you know. We expanded. We found space. There were more of us. We moved. We found space. There were more of us. We moved. So you can see what happens over generations and generations. Yeah. The number of individuals isn't really high here either. Don't go thinking the millions of people we have today. So we had Homo sapiens arrive in Australia. You know, records are showing up to 60,000 years ago, and there would have been, if not connected by land, lower sea levels. So land could be seen. Yeah. There was going to be no great exploration. Like we weren't going to set out from ships and sail around the world. But if you could see another landform, we had enough intelligence to use a a log, make some sort of crude floating craft, or wade across water to get to other places, yeah? But once here, 60,000 years ago, then sea levels rose and Australia was isolated. Next week, well, during the week, I might make a special of the out of Africa, out of China story. So it basically says that the out of Africa one has the most evidence and is the most sort of supported theory, yeah? That all our ancestors, we evolved here and we went, yeah? The out of China says, well, our ancestors evolved here, yeah? Modern person evolved here, well, here in China, and went back. Does that make sense? So it's quite complicated. Actually agrees with the biblical narrative. Which one, Annabelle? Africa. Yeah. I don't know. I don't know much about the Bible. But okay. Now, so there is an out of, now why is this a big thing? Because we are finding more and more evidence, right? And remember what evidence does. Evidence influences theory. So could there be a day where we find more evidence where the out of Africa theory gets totally turned over and the out of China theory for our species? Yeah, it's a growing one. It's been around for a few years. Okay, it's not widely accepted, but there's more and more evidence to support it. The out of Africa is still the strongest case at this stage. But a theory, I'll come back to this. This is why I'm talking about it, because a theory is the best explanation we have for something at the time, right? So at the moment, all the evidence supports the out of Africa theory for our species. But there is growing evidence for another theory. So we just have to wait and see. This is why learning is such a wonderful thing. So what makes us different? And I think Annabelle got onto it for sure. What makes us different is we had effective communications. Yeah? All our humanoids could communicate, and there were changes to our physiology as well, which helped with that, right? So physically our bodies changed. So even our early ancestors could give a message and get feedback, right? But we got better and better at that. Neanderthals, I think I said last week, if here's the very first Neanderthals that we found, you know, Neanderthal remains, and say it's about 1 million years ago, right? There's Neanderthals, and then we find the sort of last lot of Neanderthals, yeah? What changed here with Neanderthals, with their tools, with their drawings? What changed? Not much. It sort of indicates that they lived their life, died, that not much information got passed on, yeah? They lived pretty much the same life over and over and over. There was no real changes. Does that make sense? Yeah? Right. But what was the difference between us? Well, we could make slight changes. We had a memory, we could record information, we could pass on more complicated messages. So this video, what makes humans different, is really, really interesting and critical. But collective learning. Why did we move into new environments? Yeah, now this makes up a whole sort of threshold on its own. But we could learn, we could pass on information. Yeah. We could do that. Now, writing has only been around for about 5,000 years. Yeah, I think a bit longer, maybe. But our species have been around for 200,000 years. How did we pass on information? With stories and songs and pictures. Yeah, we can use quite abstract thought. Yeah, do you know, off Queensland coast, where of course now is occupied by the shallow waters where we find the Great Barrier Reef, right? 10,000 years ago, the ocean levels were different. That was not ocean, right? That was like a lowland where there was land, right? There's indigenous song lines from parts of Queensland, so songs that still exist today, which talk about hunting and gathering and the good things to be found out on that land. And in the last 5 or 6 years, there's been a whole lot of evidence done by geologists which support that. Isn't that fascinating? So Indigenous cultures have held these song lines for years, about thousands of years, about being able to access that area and the good hunting that was there and the good conditions that were there. And sea levels rise, and of course the songs stay, but the evidence is gone. But in recent times, we've found geological evidence to suggest that that was right. Crazy stuff, isn't it? It's just awesome. So it's not, we didn't learn to write things down till fairly recently in the piece. And when we did, that really changed things. But before then, we had songs and stories that would be passed on. And that's what defines us. We have 7.5 billion people in the world today. Do your quick, I've done this with you before, I think. Do your quick 2050 age. Tap in your 2050 age really quick. What will you be in 2050? Yeah, look at all you millennials. Hey, Sonia, I'll still be older than you. Right. Well, right. That's great. So you got your ages? Oh, look at you. You're still younger than me. All right. Well, guess what? You'll be sharing the planet with at least 12 billion others when you're 50. Yeah. And how are we going to maintain that? How are we going to manage that? We do that through our collective learning. And by the way, 12 billion is the absolute carrying capacity of the planet. And the good news is when it hits 12 billion, the modeling says, here we go again with modeling, the modeling says it levels off, right? It won't keep going. It'll sort of level off at about 12 million. So hieroglyphics, someone asked a question about hieroglyphics, considered writings or drawing. Well, it's the beginnings. It's the beginnings of writing, yeah, where pictures start to make way for I'm just trying to write it here. It's the beginning. It's the beginning, okay? As in, what if the population grows? Well, modelling says, Seb, it won't grow more than 12 billion, right? Because the amount of people that die, the death rate and the birth rate will just maintain a population. Yeah. Okay. So let's go to the next slide. So we don't rely on geniuses, right? We rely on our collective knowledge. Yeah. Now remember, up until 12,500 years ago, we pretty much lived as hunters and gatherers. Yeah, right. So that meant small groups covering a large area. So large area. So contact was pretty small. Exactly. We stand on the shoulders of giants, and you just stole a key phrase that I was gonna use, Annabelle. We stand on the shoulders of giants, and we build generations. So that doesn't mean, no, it's good, Annabelle. That doesn't mean that our earlier ancestors weren't clever or smart, right? You just got to keep thinking of this. How do we work? Well, the more people the more innovators we have in a room, the more innovations we're going to get. Yeah. So when we're in small family groups wandering over large areas, our ability to communicate and share ideas is really minimal. And it's not until last 12,500 years, when the agricultural revolution started, that we had first time saw big concentrations of people, and that gave surpluses of food. Whoops. Surplus of food, which meant we didn't have to spend our whole time looking for food. Now, we're going to get into this next week because there's some give and take here. Yeah. Why did the agricultural revolution started within a few hundred years, right? In about 12 spots around the world, right? Because of some geographical features that were quite unique to that area. Yeah. Not every place lent itself to agriculture. So that's why some people maintained a hunter-gathering life. Some groups of people maintained hunting and gathering lives, not because they were primitive, but because the environment they were in did not permit a sedentary life, a farming life, which wasn't easy. A lot of traps with the early farming. But what happens is, once we start to get congregations of people, we started to see a congregation of ideas. Depends on your modelling, Alexander. So the ranges do model from 9.7, but I go with the outside 1, 12 or 5. Okay, so the BHP state that Indigenous Australians maintain a foreign lifestyle, which I dispute, as there is currently. Exactly, yes. And I'm a big fan of Bruce Pascoe's work. Dark Emu, Black Seeds is the book. I recommend you read it. It's a text in one of my other subjects. And Little Dark Emu, you think it's a children's book, but it's a younger adult's book, really. And Dark Emu is actually out of press at the moment. I couldn't get a copy. I was trying to get my own copy since Christmas, but they haven't done a print rerun. I was able to get a copy of Little Dark Emu, and I also bought the six CD pack. And guess who reads it? Bruce Pascoe. So I love it. Yeah. So yes, now Bruce Pascoe, let's just fill this in. In fact, I've contacted, I've spoken to David Christian about this, and I've contacted BHP about this, that area of Indigenous Australia needs to be updated. And if you haven't read Pascoe yet, I suggest you do. Pascoe essentially is an Indigenous man, Indigenous Australian, and an academic. And his research focused on the notes and illustrations from the early explorers. And he talks about, just in brief, I won't go into too much, but in brief, he talks about some of the early explorers writing down the acres and acres of farmland, or acres and acres of cultivated land they saw. They talk about the stone buildings Indigenous people made with tonnage of grain in them. Yeah. Now, of course, why did this not get widely spoken about? Because of terra nullius. You know, Australia was claimed because no one was using the land. So it's a really different perspective, and well, a truer perspective of how Indigenous Australians lived. And even quotes like early explorers coming along and finding a vast river valley with green pastures and you know, clear streams and not a tree in sight, and going, oh, this must be a gift to us from our God. But no, it's the result of 20,000 years of burning by Indigenous people, you know, to get the land like that. So it's a really interesting perspective. So yes, thank you for bringing that up. Whoever did that, who put that up? I'm just going back through. T. Thank you. Good bring up. I like that one. Yes. I've been trying to weave, fire stick farming. I've been trying to weave sections of Pasco into this subject, but it's just a little too full. But I was planning to share a reading with you from Pasco for next week. So that's really great. Thanks for preempting that. So good pickup. I like the way you guys are thinking. And it's good to see stuff from other subjects, you know, influencing your thoughts, you know, how the stuff from the ICK subject is front and center when you're doing your science. I think that's brilliant. Right. So it's not about geniuses, it's about gathering. Okay. And collective learning is about access to information. Yeah. It's our infinite capacity for memory. So collective learning is key to all this. Because we share information, we get power over our environment and even over other humans. Information is power. Yeah. And in your lifetimes, power has, information has gone to a whole new meaning, hasn't it? Yep. We can talk live time to anybody, anywhere in the world. You know, that was unheard of. I had friends overseas when I was a kid, and I would write to them, and it would, you know, I'd send a letter, and it'd take 2 weeks before you got a reply. It was quite different to what we find now. And it's interesting because, yeah, pretty much like a pen pal. The old pen pal thing used to be great. So it's not all beer and Skittles, though, isn't it? It's not all wonderful. You'd think, because we've got this collective knowledge, collective learning, and this ability to communicate so instantly, that everything would be wonderful. Well, no, because we do have human nature. Yeah. And it's interesting. I don't know if that's making us smarter, though. We just ask Siri. We don't need to remember anything. Yeah, it's quite dangerous, isn't it? It's quite dangerous if we start to lose some of those basic skills. Yeah. But then it's also quite exciting. Like, we don't have to invent a computer, we just have to use it. So that opens up a whole lot of global questions that we can address, and we'll get to that. Okay. Right. So physiologically, we changed a lot, yeah? Much bigger brains, we get changes to our jaw, and we get changes to our neck, yeah? So we have some physiological changes where we can make more sounds, right? Where we can have the ability to speak. We could use symbols. So I'm just not going to read what's there. You can have a look at that. But this was the big thing, our imaginations. We could talk about something. We talk about an image, a concept, and get it across to someone else. You've heard the phrase, pigs might fly. Pigs will fly, or pigs might fly. We can plant that picture in our heads, can't we? Right. That's really unlikely to happen. But through language, we can develop this concept in the ether, if you like. Does that make sense? This is just an example of how powerful our language and imagination is. But of course, this is never likely to happen. But once I say that, you know that what I'm referring to a really unlikely event. If I say, oh, pigs will fly. So here comes that creativity in our language. So where have we gone? Okay. Modern humans, Homo sapien, was a revolutionary event in the history of Earth. Yeah? Because we've done something. Now, on modern humans, I'm not talking about Homo sapien. I'm talking about modern humans, right? Yeah? So here are the modern humans. Here we are, Homo. That's us. Why was it revolutionary? Because we were the ones that really started communicating and learning across generations. Yeah? So this is pretty... I'll just get rid of all that. I've made too much of a mess. I want my eraser. Dip. Now I'll get my pen back. I love this. I know you hate it, but you know, what can I say? So this is modern humans, right? Wow, revolutionary. This is where language started. Yep. And once we started language and using our understandings, what would you argue, Annabelle? This is good. Let's have, Annabelle wants to argue with me, which I think is fundamental to good science. Yep, what would you argue? I would argue that collective learning is not the only thing that distinguishes us from animals. Okay, what else is there? You don't have to answer that right away. You can simply say you disagree and you'll get back to me. But okay, Annabelle, I'll concede it's certainly the start. Yeah, we do have morals. Yes, and they're often inbound in culture. Okay. Well, just for argument's sake, Annabelle, let's just say it's the start. Language really started things, because from language we did get culture and we did get social norms. Slowly, yeah. We did get we did get our social norms, but they changed too over time. Yeah. We'll look at this in great detail next week. So this is a nice way, we're getting near the end, but it's a nice way because infanticide in some of these, in our society, Homo sapiens, and I assume in other groups was a common thing. So that's where when there's too many infants were killed or abandoned. Yeah. The same with old folk. Like the geriatrics, geriocide. Yeah. The older people were abandoned. And that was seen at the time as morally correct, I would imagine, because it meant the survival of the tribe. Yeah. But wouldn't morals come from collective learning? Yeah, yeah. Yeah. This is nice and juicy to get into the next week, okay? So it's good, these questions, and I'm glad they're being asked. But what we do know, and the point I'm making is from here on, where modern humans came, things changed, right? Because the planet wasn't dictating, wasn't just in control, dictating everything to us, yeah? For the first time, we had a species that started to push back a little against the planet. Does that make sense? All right. So things were getting much more complex. We had a much more varied diet. Yeah. Varied diet started putting extra protein into a brain. We were comparatively supercharged. Yeah. And then natural selection keeps working. Improved diet, better brain, more dexterous fingers, language, communicating ideas. So we really took off as a species. Yeah. Every continent except Antarctica. But there's a catch. Oops. Remember how everything's random? We got down to about 10,000 adults. Yeah, we were at one stage as rare as mountain gorillas are today. Yeah, this is Homo sapiens. 10,000. Yep. Scary, isn't it? This is why collective learning is really going to be a big focus, is a big focus of our understanding. Evolutionary processes are fragile. So this is what we'll get into next week, Annabelle, which is what you're alluding to. Language allowed us to share ideas. And not just concrete ideas, but really creative ideas. Yet, we stand on the shoulders of giants, yeah? But in actual fact, it sort of looks like this, yeah, over thousands of years. And then in fairly recent times, yeah, that's what's really happening with our knowledge. Yeah, so this is 200,000 years ago, and this is in the last couple of hundred. Yeah. All right. Now, then we hit this. Then we hit farming. Then we hit the agricultural revolution. And I've said a number of times now, this is 12,500 years ago in half a dozen places around the world within a few hundred years of each other. Yeah. But once we did that, and we could, it wasn't long after we did this, it was just a couple of hundred years after we started agricultural practices that we started to see the first cities, the first towns where we have a few thousand people living. Yeah. And this is where we really start to see collective learning. Collective learning take off. There's nothing brilliant about these people except they had the opportunities to share and talk really, really regularly, which is quite different from a hunter-gatherer lifestyle. Yeah, and it wasn't easy. So, oops, that's the end. That's available for you. That's all I wanted to get through today, which is a fair bit, understanding our species, linking it into evolution. You've done this in comparison, in conjunction with the module and BHP. You really should have a thorough understanding, well, pretty broad understanding really of evolution, understanding metabolism, homeostasis, reproduction and adaptation. Then we look at our species and our bigger families. Okay, got to go, Sebastian. Fine, no worries, see ya. Okay, so, and understanding our species, it isn't this lovely smooth line. Evolution is quite fragile and random, but natural selection drives it all along. We didn't just appear, we're the product of evolution. There we are. Okay, might leave it there. I'll stop talking and I'll open up for questions. No problem. Yes, there is a Kahoots. I have a Kahoots. Is it threshold 5, threshold 6 Kahoot? I'll open up Kahoots. If you want to play, you can. If you don't. You can do it yourself later. It is threshold 6, I'm sure. I'll open it. Probably a silly question. Natural selection for cinnamon. Yeah, yes, they are. It's a good question. But when we think fittest, we think athletic fit, right? Think best fit, right? Yeah, so survival of the fittest isn't necessarily survival of the athletic fit person, it's survival of the best fit. The survival of the fittest, the one that fits into that niche the best. Okay, catcher. I'll open this. There's no obligation. You can play. Oops, I opened the wrong one. You can jump in and play along with this if you want, or you don't have to. I don't care. Oh, well, you know. Yes, Alexander, I do think that. I do think that's why storytelling, it is so tied into our DNA innately. Yes, Alexander, I really do. I think that whole listening, intrigue, interest, the ability to sell an idea, convince someone else of an abstract thought, yeah, it is really key in us. So that's, yeah, I think storytelling is really part of just, we're hardwired to it. Yeah. Yeah, that's a really good. I like the way you're thinking about this, Alexander. This is good. Annabelle's been giving it some thought as well. Well, I'll open this up. Now, any other questions? You got plenty to do. I'm going to stop. Oh, no, I'm not. I'm going to keep sharing. I'm going to stop the recording.